Morning all, and today I'm going to do a one-day project to try and use these little wireless transceiver modules, the nRF24L01 plus modules. So here are some of the standard modules that have the PCB antenna, and also I have this high power module which I opened in my postbag number 6 video. That comes with its own antenna, and there's a power amplifier on the board. I also have this, which is some sort of interface unit for the nRF modules, but I've since done some reading on this and I don't think there's any code in here. Someone has made code for this thing, but I'm not intending to use that today. I've got a couple of these base boards, and these are for the nRF modules to plug in, and they provide a nice easy access to the data pins and also a 3.3 volt regulator to provide a power source for this thing. Now these things are apparently a bit flaky on the 3.3 volts, so there are lots of capacitors on here as well, but I don't think I'm going to use these today because for people watching this video that don't have these, it would be the wrong thing to do, I think. Now also here I've got a couple of ribbon cable strips. I normally tear these into runs of 10. We only need 8, but I'll just keep them as 10. I've got an Uno. This is a clone Uno, but I like this one because it has both the female and the male pins, and my wire strips are only female to female. And also here I've got a Nano with a Nano breakout board. Again, that gives me the male pins so that I can attach my female headers. I just need to solder this Nano onto its header strips. So just going back to my postbag number 6 video, where I opened the high power transceiver. I had a little conversation with SuperDAL, and SuperDAL was saying how he'd powered these things up and got them to work, and I said, which library did you use? And he said this one, which is the Maniac Bug RF24 library. And he also pointed me to this link which goes to a page. Let me go to the top of that, and that gives lots of information on how to use these nRF24L01 transceiver modules. So one of the first things you come across in the how-to is note power problems. People have been having trouble with this thing because of the 3.3 volts. Connect a 0.1 microfarad to 10 microfarad capacitor directly on the module from 3.3 volts to ground. And this provides a little sort of power supply, local charge source, so that when the transceiver fires up and starts transmitting and draws a lot of current, it has some pool of energy that it can draw on. So I'm going to put those capacitors on right away because I just don't want to have any problems with intermittency. So I'm going to do that right now. So soldering iron warming up, I'm going to use a 3.3 microfarad tantalum capacitor for fairly obvious reasons. I've got quite a lot of them. And I've got my nRF module ready to be soldered onto. Now the capacitor will go directly between ground and 3.3 volt VCC, pins 1 and 2, so brown and red here. Pin 1 you can see is identified by that bit of silkscreen square on the corner there, and it goes 1, 2, and then 3, 4, 5, 6, 7, 8. So the capacitor I'm going to put on the top side of the board directly on pins 1 and 2. So there's my 3.3 microfarad capacitor soldered between pins 1 and 2. 1 is ground, 2 is VCC 3.3 volts. Got to get the capacitor the right way around, of course. I've done that on 2 of the modules, and while I was at it I just soldered the header on my Nano as well. So I think we're done with the soldering iron. Now we can get on with the wiring. So just flicking through the how-to, we got some nice photos there, including the high power transceiver unit. And then you come to this diagram of the pins, the board layout with its pins, and also this chart which shows the RF module pins and the signal names on the left, color codes for the wiring. I'm going to stick rigidly to those color codes. So brown is 1, red is 2, to make things nice and easy. And the Arduino pins for the RF24 library. So it looks like from this column we're going to be using 9, 10, 13, 11, 12, and possibly 2, but I don't think we're going to use the IRQ line. So I've already connected up one of the ribbon cables to the first nRF module, brown, red, orange, yellow, and so on, and that follows this numbering sequence where you can see the pin number and the associated signal, and also the way the pins are actually laid out on the board. It's 1, 2, 3, 4, 5, 6, 7, 8. So I've connected the first 2 wires, which are brown and red. Brown goes to ground. Now, crucially important, let me get a pencil. Yes, critically important is that the nRF modules are 3.3 volt. So I've connected my red wire there to 3.3 volts, not 5 volts. Now they have 5 volt tolerant data lines, so when I start connecting up all the D connections here, it doesn't matter that we're squirting 5 volt signals into the data inputs because they're 5 volt tolerant, but the VCC must be 3.3. Now where does this 3.3 come from? Well, it comes from this chip here. The CH340 USB to serial driver actually has a 3.3 volt regulator inside it. This one here is a 5 volt regulator for the high voltage input there. So this is where 3.3 volt comes from. It doesn't have huge amounts of power, but apparently, according to the how-to, it's enough for these regular modules. The one with the onboard antenna probably isn't enough for the high power one with the external antenna. But there it is, red on 3.3 volts. So now let's start connecting up the rest of the signals. So what do we got? We've got orange on 9, yellow on 10, and then there's a break. So let's do those 2 first. Yeah, so in fact it's orange on 9, yellow on 10, blue on 11, purple on 12, and green on 13. And those are all visible from that table there. So now I've connected an identical ribbon cable to the second transceiver module, but there's a bit of an issue with the 3.3 volts on the nano and the breakout board. It seems that the 3.3 volts here on the nano, this pin here, comes from the CH340 chip, the USB to serial chip here, but it doesn't go anywhere on where it plugs into the breakout board. 3.3 volts is available on these pins here, but that appears to come from this 3.3 volt regulator on the board. Now I don't suppose that matters. It doesn't matter where the 3.3 volts comes from, and that's the only accessible point that has a male pin, so I'm going to take the 3.3 volts and the ground for pins 1 and 2 from here, and then the remaining connectors will go on to the digitals in exactly the same way as I did for the Uno. So scrolling down on this how-to, and we're reminded that there are problems with 3.3 volts. Stick your capacitor across pins 1 and 2, and a reminder here in red, VCC must go to 3.3 volts, not 5. Okay, so now we come to software and libraries, and of course the first thing to do is to go to GitHub and get the RF24 library and install it in my Arduino IDE. So get Maniac Bug's excellent RF24 library, download it here. That takes me to Maniac Bug RF24 on GitHub, and down here there is the download zip button, so I'm going to do that. I probably won't go through the entire process of installing this. Where's that? Yes, that's downloaded there, to RF24 master. If you go back to the how-to, it does give information on renaming the renaming the zip folder that comes down, removing the master bit, and so on. It's all there. The main issue seems to be characters like dashes, which have to be removed. So I've just shortened that to RF24. I've gone into my IDE and installed it. So now in examples, and come down right down to the bottom. I've just nudged the mouse. Where is it? nRF24, and there are a set of examples files that can be installed into the Arduino. So on the how to it says, see our page about installing libraries here, that's fine. When you have the library installed, you can run the examples below, and I think that's what I'm going to do. I'm not going to use the examples that came in with the library. I'm going to use these examples. There are two here. There's a transmit joystick example, and a bit further down there's the receive joystick. And what this is doing is it's taking two analog pins, here they are, A0 and A1, and transmitting the values that are on those analog pins to the other Arduino, and then they are, in the receive file, they are printed using serial print. So they'll go to the print monitor. So let's load those two pieces of code in. I'm probably going to have to just simply copy and paste the code straight off this page, try to compile it and put it into the two Arduinos. Let's give it a try. So the first one I've simply called nRF24L01, and I've managed to successfully install that into the Uno. No errors. Of course, there's not much indication that it's doing anything, apart from the LED D13. Let me just shield that. You can see that that's lit. Now I can see that that's dimly lit. In fact, compare it with the on LED. So that is flickering. That is switching on and off. Now D13, if you look at this list here, pin 13 is S clock. So there's a little hint there that S clock is actually oscillating. So I'm hopeful that that's transmitting. Let's put the receiver program in the other Arduino and see what we get. So here's my other Arduino file, which I've called nRF-RX for the receiver. And I've just clicked the serial monitor and look what we've got. This is a eureka moment. Actually got some data coming out of the Nano in this case. There's my Nano there with its transceiver set to receive. The Uno now I've just powered up with one of my little power banks, so that's transmitting. There's the transceiver for that. Transceiver for the receiver is here, Nano, and serial monitor data is coming out there. Now, of course, on the transmitter, the Uno, I've not connected anything to analog pins A0 and A1. They're just floating, which explains why we're getting this rather nonsensical data. But if I just put my finger on analog A0 and A1, you can see that immediately we get noise and different data as I sort of connect those analog pins to various other pins. So it's definitely working. It's definitely reading analog A0 and A1 and transmitting the data. Result! So I'm now going to take my essentially standalone transmitter consisting of the mobile power bank, the Uno and the transceiver with its soldered on capacitor, and I'm going to walk it down the hall to the front door and just stick it there on the mat and see whether we can pick it up from that distance. So there it is near the front door. That's about 7 or 8 meters away. And what have we got? Yeah, we're still getting the A0 and A1 data coming through. Time to take it out into the garden, I think. So I've now put the transmitter on this table in the garden. There's the module there, and my workshop is down these steps. There's my solar power battery bank, and the workshop is there. Can we see the module on the bench? Not quite, but anyway, let's see if the data's coming through. Well, now this is interesting. The data is there if I hold the transceiver up with my hand like that. If I push that down onto the bench and let go, it says no radio available. If I lift it back up, we've got the data. Drop it back down. Sometimes it's got the data, sometimes no radio available. So that seems to be the limit of its transmission, which is not unexpected. It's about 20 meters with a couple of walls in the way. I think that's pretty reasonable. And here's the module in my hand. I'm trying to show both at the same time. If I sort of tilt it, no radio, tilt it back the other way, and we have data. So typical of wireless transmission systems, highly sensitive to sort of orientation and obstacles and things like that. But that's a result in my book.